let's talk about cryptocurrencies. This is, I think, a really good tweet that just the other day that sums it up real well. Algorithms, I want to solve a problem. Data science, I want to understand a problem. AI, I want to solve a problem but not understand the solution. Thus my Rage Against the Machine Learning t-shirt. And blockchain, I want to be a problem. But wait, what about the venture money? Isn't there a ton of venture money in the cryptocurrency space right now? Yes, there is, because securities fraud as their business model. So the old venture capital model is you invest in several companies. One or two end up thriving, and those you either sell to the public or sell to another company. The A16Z models these days, though, is security fraud as a business. You invest in several blockchain startups. Each startup issues their own tokens promising something eventually. These tokens are really unlicensed securities. It's blatantly illegal, but not currently enforced. A16 gets a ton of these tokens. They sell the tokens they get to retail suckers, getting the cash out they would get in an IPO before the company is able to do anything. And OK, it's grossly illegal, but let's assume the SEC actually wakes up and enforces the bloody law. Well, the startups were the ones issuing the unlicensed securities. A16Z was just buying them. What that company does, it's not my concern. So why there's so much venture money in the blockchain space right now is because the venture capitalists have figured out securities fraud as their business model. There's a recent rebranding. How many have heard of the Web3? The cryptocurrency is going to take over. Let's bring the unstoppable, censor-resistant blockchain power to the web. Now, the current web is decentralized. There's a lot of entities, but they're named entities, and you have to contract with a couple. You have to contract with a DNS provider, and you have to contract with a web hosting provider. And so you have this nice little model where the user's browser is running half the computation. Your stuff is running the computation on the web server. You've got yourself a database. It stores the data. It's all good. And yes, there's censors. If you want to do something that is totally reviled by everybody, like, oh, say, child exploitation material, nobody will host you. But you can be a literal Nazi, and you can find companies to host you. So we have censors in the current system, but you get to choose your censor. It isn't just an arbitrary government. It's specific environment. You can arbitrage your choice. So if you want something that pisses off China, like the grand tribute to Winnie the Pooh, host in the US. If you want something that pisses off the US, well, Ecuadorian embassy, Russia, etc. And this is what the current web looks like. I'm going to show you the Web3 vision. This is by not a doubter, by the way. This is the Web3 vision as encapsulated by a supposed evangelist. This is not a parody. We still have our front end. So we have not removed our gatekeepers. Instead, what we've done is we've added a little bit of the computation is instead paid for in cryptocurrency by an extension in the user's browser. So the user's browser now has a signing function to sign away cryptocurrency. We have back-end, the Ethereum virtual machine. We've got centralized providers to make interfacing with that ethereal virtual machine usable. We've got centralized providers to allow us to deal with the data. We've got centralized providers to provide scaling. And we have a distributed storage architecture that actually is really just BitTorrent on steroids, so you still need seeders anyway, so you still have data providers. How many gatekeepers have we removed from this? None. How many gatekeepers have we added? A hell of a lot. But you could argue this is useful because, hey, we now have the unstoppable power of the Ethereum virtual machine to protect our distributed apps. Let's actually go through the math. The Ethereum virtual machine is an ugly little stack machine. And it runs on gas. Every instruction has a fixed amount of gas that it consumes. And as a result, the simplest computation is 3 gas, 256-bit addition. 2 million gas per second. So we can do 60,000 or 600,000 additions per second on the Ethereum blockchain, globally, worldwide, total. All of Ethereum, burning as much power as a major country, can do 600,000 adds a second. Because all the miners are doing the same computation. Cost to use, $250 a second. My favorite little Raspberry Pi, 3 billion additions per second, and it cost me 45 bucks to buy forever. The Ethereum world computer is 1/5000th as powerful as a $40 Raspberry Pi. What the? What about non-currency blockchain applications? Well, let's put a bird on it. Private or permission blockchains, as I said, we've known how to do that for 20+ years. The only value you get in saying blockchain is idiots throw money at you. Public blockchains can't work. They're the cryptocurrencies. And in general, anybody proposes a blockchain solution to something doesn't actually understand the problem. Solve voting, electronic medical records, by putting what data, what formats, what honesty, what enforcement, how do you know the data is right, in an append-only data structure. How you store the data is not the problem. Let's go with a concrete example. This is from my experience. This is why I have my iron law. A couple of years ago, there was a blockchain class at Berkeley. I screamed internally. There was another one last semester. I screamed internally again. That first one, I attended one session to give a short rebuttal. There were 2 outside experts, though, who presented before me about the revolution that blockchain was going to present. This was an actual example. Vaccine supply chains. This was an example back from 2018, but it's still pretty good today. That in order to transfer vaccines, you need to keep the supply chain suitably cold. It's called a cold chain. If it gets too hot, the vaccine is ruined. One expert was, you could solve this problem in India with blockchains. And said it honestly with a straight face and actually believed that. Now, I'm going, no. The problem is sensing. How do you know if the vaccine has gotten over temperature? The problem is data inclusion. Who includes the data? The problem is you don't need to because you just use a $1.50 shock watch label. You stick one of these labels on and it changes color if it ever goes out of temperature spec. And this is why I have my iron law of blockchain. Blockchain solves exactly one problem. When someone says you can solve X with blockchain, they clearly don't know anything about X, and you should just ignore them. It's a great filter. That is the one problem blockchain solves. There is one innovative new stupidity in this space, though. Smart contracts. I love smart contracts. I love smart contracts for the comedy gold. The idea is, hey, contracts are expensive. So let's take standard contracts that are written in a formal language called legalese. It looks vaguely like English. It's not, but it's similar. And let's replace them with things written in a horrid language that looks vaguely like JavaScript, where in general we can't update. First of all, how's that going to make things cheaper? Standard contracts. The whole point of a standard contract is it doesn't cost anything to draft a standard contract. And then we ditch the exception handling mechanism. If I can steal from a smart contract and it says yes, am I violating the contract? Oh, and backstory. The reason why these things were created in the first place was Vitalik Buterin was upset that World of Warcraft nuked his spellcaster, or nerfed his spellcaster, and wanted inviolable, immutable code so that they could never nerf me again. I'm not kidding, actually. That was his reason. But that's not what they really are. What they really are is finance bots, small programs that work on money. Now, we have had finance bots for decades. The difference is the finance bots we've had for decades are not public. You don't interact with them directly. And they're running on reversible fabrics. So if something goes wrong, they can press an undo button. When you go off into the real world and have a 401k, invest in index funds. It means hand your money off to a finance bot that happily invests in the broad stock market, and there's plenty of math saying that's the optimal finance bot. So finance bots are an old idea. Smart contracts are, hey, let's make the finance bots run publicly so Joe Rando can directly interact with the code, and run it on an irreversible fabric, so if the code screws up, there's no undo button. So your code has to be perfect. Anybody else think this is a stupid idea? It's great for comedy gold because the result is a smart contract, as David Gerard puts it, is really a piñata for black hats to whack on until the money spills out. Right from the start, they've been million-dollar bug bounties. The first major smart contract, the DAO, was a voting mutual fund as a smart contract. It got 10% of all Ethereum invested in it before somebody stole all the money due to a bug in the contract. And then the Ethereum developers go, code is la, ha, ha, ha. We're changing the code of the underlying cryptocurrency to undo the theft. Who's the real theft? The guy who followed the code, or the guys who changed the code to steal the money back? You think that would have stopped smart contracts as an idea? Nope. The parity multi-signature wallet, the idea is cryptocurrencies are hard to do, so let's make multi-party checks. So rather than one signature, you have to have 3 signatures. Good idea, except that there was a bug. The bug basically allowed somebody to go up to the wallet, go, hey, cryptocurrency wallet, you belong to me now. Hey, cryptocurrency wallet, give me all your money. And this resulted in millions of dollars of cryptocurrency stolen. It wasn't as big a disaster as it could have been because a white hat saw this happening, did his own theft, and then took the stolen money and handed it back to the victims. Then a subsequent bug on the updated version, somebody went up to the master contract that all the wallets depended on. Hey, master contract, you belong to me now. Hey, master contract, just kill yourself. And so the master contract killed itself, and tens of millions of dollars worth of Ethereum are now locked up forever, immutable. Oh, and the primary developer behind this is the guy who invented the bleeping programming language for the smart contracts in the first place. What? You now have these decentralized autonomous organizations. let's get together, create an organization where we all invest, we all get a vote. This is a centuries-old idea. It's called a joint stock corporation. Now, a joint stock corporation has a fair bit of real legal world paperwork because it gives liability protection. DAOs do not. DAOs are more of a general partnership, or, as I like to put it, a conspiracy. Basically, every DAO governance contract sold on a blockchain is an unlicensed security, and they're breaking security law. So, conspiracy. Why talk about this at all? I am an actual bona fide world-renowned expert in this area, I'm sad to say. Because it has been one of my research focuses for the past 9 years. And let's face it, one of the advantages of a place like Berkeley as opposed to, say, your local junior college is you actually can talk to experts in fields who are, well, actually, no. If you want viticulture, Napa Valley is really good. But anyway, you have experts. So this is an area that specifically touches on my expertise. And basically, I've been mining this space for both academic papers and comedy gold since 2013. And no, that's not a typo. Because I want it to die in a fire. Basically, there's no value in this space. None. Zero. Zilch. Zippo. And I'm going to tell you why. Private blockchains are a 20-plus-year-old idea. And we'll see that. Public blockchains are grossly inefficient without actually being decentralized, like criminally inefficient, and only are good for cryptocurrencies. And cryptocurrencies don't work as currency unless you're a criminal. The entire space is a self-assembled Ponzi scheme. But it's refused to go away. But it also touches on a lot of real-world security issues that often have nothing to do with actual security. But it gets even more fun. Here's a challenge to all those in the audience. Buy $1,500 worth of Bitcoin now, right now, without needing $1,500 cash in hand, transferring money to an individual, or having a pre-existing relationship with a Bitcoin exchange. You can't. Because everything in modern banking is reversible if it's electronic. It has an undo button. And the undo button is critical for mitigating fraud. They can go, oops, undo, 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 go back. But you can't in Bitcoin. Bitcoin is irreversible. So for seller of the Bitcoin must be doing either one of three things. They are either taking cash. Bitcoin ATMs don't take ATM cards, they take cash. Have an established relationship or extend so that they can extend the buyer credit, or take a deposit from a buyer and wait a couple of days. There's no other way to do it. In fact, this gentleman here, by the name of Steve Wozniak, tried to sell $70,000 worth of Bitcoin one day, threw it to a private party on PayPal, and only found out after he transferred the Bitcoin that it was a compromised PayPal account and the money got taken back. I think he can afford the $70,000 loss, but that's not a good system. And relatedly, this makes it very easy to steal. You compromise the private keys, you steal the Bitcoin. I've got a great paper on it, How to Make Money in Bitcoin in 10 Easy Steps. It's on the Buttcoin Foundation. But the result is you cannot store cryptocurrency on an internet-connected computer. If this is supposed to be the internet of money, you should be able to have it on your internet-connected computer, right? Wrong. You want to secure your system? Have a small Bitcoin wallet on it. When it gets stolen, you know you got compromised. I'm not joking. We actually detected a compromise this way in the early days, back in 2014. Where a student created a Bitcoin wallet that we monitored. We were deploying it on some systems to see if bad guys were starting to steal Bitcoin. and he had a copy in his Dropbox account, and his Dropbox account got compromised, the Bitcoin got stolen, and we knew about the compromise within a minute. Great, wonderful. But at the same time, you can't outsource. If you store your Bitcoin on an exchange, there's no insurance. There's no deposit insurance. So not your keys, not your Bitcoin. Talk about a security landmine. There's even more. So the primary tool these days that people are using is browser extensions like MetaMask. These are horribly opaque to use. So like a bunch of experts in non-fungible tokens were tricked by a phishing attack into having their MetaMask wallet sign basically a contract saying, I sell all my monkey JPEGs for $0. And the attacker just sat on that for a few weeks and then transferred all the monkey JPEGs from OpenSea to his wallet and then resold the monkey JPEGs on OpenSea and then took the money and ran. There's this dream in the cryptocurrency space. Decentralization, trust nobody. The entire system is trustworthy, but every actor is not. Now, first of all, this is one hell of a nihilistic worldview. But secondly, it doesn't work, because this requires that there can never be a small group that can change things. And OK, the cryptocurrency community thinks it's a leap of faith, an article of faith, that such decentralization is a good idea. The only thing that buys is the crime, but it's a lie. The code is inevitably developed by one or a few groups. And a concrete example, in the early days of Ethereum, Ethereum has this mantra, code is law. Well, 10% of all Ethereum got invested in a buggy smart contract. Somebody came along, took all the Ethereum, and then what did the developers do? They go, you know that code is law, no central authority, no masters, bullshit? Yeah, it's bullshit. We're changing the code to steal the money back because it's our money you stole. If you believe there should be no central authorities, cryptocurrencies are the only solution. But this is crime. Drug dealing, money laundering, criminal payments, gambling, attempts to hire hitmen. The only economically productive use of cryptocurrency is crime. They're also really fun to steal. Ransomware and extortion. The current ransomware problem is on the order of tens of billions of dollars a year in damage. Billions with a B to the world economy. And it only exists because you can pay in cryptocurrency. There are some minor good uses, like you could do payments to WikiLeaks and Backpage. Oh, wait, Backpage was convicted of sexual trafficking? Yeah, OK, it's crime. Unless you need censorship resistance, they don't actually work as currency. Any volatile cryptocurrency transaction for the real world requires two currency conversion steps, dollars to Bitcoin, Bitcoins to dollars. Because that's the only way to avoid the volatility risk. Anybody know how much Bitcoin's down today? 10%, 15, 20, something like that. And so every now and then, at the various Bitcoin waves, you'd get a fair number of companies go, hey, you can buy with Bitcoin. You could never actually buy with Bitcoin. They were using a service that turned Bitcoin into actual money. But if you believe in cryptocurrency, you must never sell the cryptocurrencies. The cryptocurrencies are designed to be deflationary. That is, they're worth more tomorrow than they are today. In a deflationary currency, rule number one is never spend your Bitcoin. Every year, the Bitcoin community celebrates Bitcoin Pizza Day. This was when some guy transferred some Bitcoin to somebody else who used his credit card to order a couple of pizzas. They've even celebrated by offering a pop-up shadow restaurant called Bitcoin Pizza, which doesn't accept Bitcoin. Because otherwise you use PayPal, Zelle, M-Pesa, Square, et cetera. There's all these mechanisms that work so much better. And here's a test for you to give to anybody who goes, but Bitcoin in the third world, but cryptocurrency in the third world. Ask them what M-Pesa is. And they will go, because it's one of the most successful payment systems, started in Kenya about the same time as Bitcoin, and has been eating the third world. But censorship resistance is crime. Before the cyber crooks had Liberty Reserve, they got shut down. The only censorship resistant alternative is cash. Cash is heavy. $1 million in US dollar bills is a 10-kilogram hunk of stuff. A $100 bill may not weigh very much. 10,000 $100 bills starts to add up. And so the cryptocurrencies are the only game in town. So drug dealers started with Bitcoin in 2013. They hated it. They still hate it. It's the only thing that works. Ransomware used to be Green Dot and Bitcoin. Now it's Bitcoin only. Ransomware these days is a multi-billion-dollar industry that exists solely because of Bitcoin as a payment channel. There is this notion of a stable coin that eliminate volatility. So in order to do a stable coin, what you need is an entity that would take dollars, turn them into crypto dollars, and vice versa. We know what these are. We've had them for hundreds of years. This is a bank, and these are a banknote. And first of all, this is a centralized entity, so why bother with a blockchain? Just keep the records in a database. But even assuming you do want a blockchain, well, all the other algorithmic stablecoins, they're snake oil that have basically Ponzi schemes and stuff like that. But if you're a bank, you have a choice. You have one of three choices. You either become regulated as PayPal and Visa. You have a wildcat bank, so you issue unbanked banknotes. This is banking from the 1800s. Or you are like Liberty Reserve and end up in jail because there are obligations you have as a bank. So the security is either weak or inefficient. Proof of work is provably wasteful. There's no way to make it cheap. If you are willing to articulate the entities you trust, it is vastly cheaper. So let's take 10 trusted entities. Note that this is more meaningfully distributed than Bitcoin, where you're relying on less than 5. Each one has a Raspberry Pi that validates transactions. 6 need to be honest. This could easily process all the Bitcoin transactions without an issue. This would require 9 orders of magnitude less power than Bitcoin does. For the same level of real-world security, if you have to trust at least 5 entities. What the? Oh, and you can also have fun with self-propagating programs, because these cryptocurrencies are network things. We'll talk about worms later. But basically, compromise every node running a given cryptocurrency, and then steal all the other cryptocurrencies. So target Dogecoin. It's a fork of Lucky Coin, fork of Litecoin, fork of Bitcoin. Find a remote code execution vulnerability in Dogecoin, make it spread to all other Dogecoin nodes, and then steal every cryptocurrency on those systems. Oh, and it's written in C++. Don't actually do it, but it's a fun thought exercise. This is basically intellectual vaccination. Once you realize how bleeding stupid the space is, how incredibly brain-dead stupid it is, you'll be immune from wasting your time on them. And there are some concepts of relevance. So hash chains, Merkle trees, and Sybils are all things I'll talk about during this lecture, and those you should know. The rest, die in a fire. So let's talk about linked lists. OK, blockchains and cryptocurrencies. So a blockchain technology is a fancy word for an append-only data structure. That is a data structure where you can only add data to it, you can't remove it. It, however, has this miraculous property. It causes people's eyes to glaze over and throw money at you. But when you look at it, it actually splits into two separate camps: the permissioned blockchains and the public blockchains. A permissioned blockchain, you have a limited number of authorized individuals that are responsible for keeping the records. This is something we've known how to build for decades, and we'll show you. The public blockchains, the idea is anybody can participate as appenders and validators, so there's no central authority. The problem is these don't work because of the Sybil problem that we'll get to later. And then the cryptocurrencies themselves don't actually work as currency. They literally don't work as currency. The crypto people like to somehow think that Bitcoin invented Merkle trees, and no, it isn't. It's a 40-year-old idea. So what is a cryptocurrency? So the idea is it's a tradable cryptographic token. So the goal is irreversible electronic cash. So Alice wants to pay Bob 200 quatlus for her losing bet on the green thrall, and wants to do it electronically where nobody else can block or reverse the transfer. So the idea is, let's have a public ledger. So this is what the blockchain really is when people speak of blockchains. For cryptocurrencies, is a public ledger. So a public Excel document that says Alice has 3,021 quatlus, Bob has 21, Carol has 1,028. And the idea is people can only add items to the ledger, not remove them. So this Google sheet gets pretty big. And the big idea of the cryptocurrency is Alice writes and cryptographically signs a check saying, I, Alice, pay Bob 200 quatlus. We add that check to the public ledger, and now everybody knows that Alice is down 200 quatlus, and Bob is up 200 quatlus. And that's it. So the idea is we have a public ledger of all the old checks. So Alice writes a check to Bob, says, hey, pay Bob 100 quatlus. Bob takes the check, looks in the public ledger going, oh, Alice, OK, yes, you've got a sufficient balance. Let's get my check added to the public ledger, and now I'm up 200. Alice is down 200, and that's it. The question is how do we structure this public ledger? Now, in a realistic system, this would be easy. You just have a trusted intermediary that keeps this ledger. We've had electronic payments for decades now with the bank doing this, that the bank acts as a gatekeeper on the ledger. The idea behind the cryptocurrencies, though, is let's add a way where anybody could be that gatekeeper. So what happens is everybody involved gathers up the loose checks, copies of the loose checks. For each check, you validate that it's a valid check, that there's payment and everything else. You bundle all the checks up into a block, staple them together with a hash and a pointer to the previous one. And now you do a lot of work. And the work is you've added one additional check to the pile that says, pay the miner the reward for the success. The hash of this total stack, including the reward check, is X. And X is just the determined difficulty factor. That one person gets a hash that's low enough, that meets the requirements. Now everybody knows it. Now everybody starts on the previous block. And this is how you get your append-only data. And so we've got our pile of checks. Alice, Bob, and Dave all have their own pay-to check. They just keep tweaking the pay-to check until the hash of the resulting stack meets the criteria. When it does, Bob goes, woohoo, I've got a valid stack. And now Alice and Dave basically start all over, pointing to Bob's stack. That's it. And Bitcoin is just the first widely deployed development of the idea. A Bitcoin wallet doesn't hold Bitcoin. It just holds private keys. So we've got our private keys. We've got our public keys. And Bitcoin's blockchain is just its shared ledger. And sending Bitcoin is simply a matter of writing a check and broadcasting it. So pay to Ross Ulbricht Legal Defense Fund the value 0.05 Bitcoin, signed by me. Whoever validates this transaction gets 0.005 Bitcoin. It's signed by this public key. Yes, indeed, that used to be my Bitcoin wallet. I don't have the private key anymore. I basically had a new computer with 16-core processor, and I needed to make sure it was working. So I just generated a gazillion Bitcoin keys until the public key looked the way that is. That's a proof of work, by the way. And you can look it up. This is Bitcoin transaction, D6, B24, blah, blah, blah. That's a SHA-256 hash of the transaction. And if you look it up, you actually see this. So you see me paying a piddly small amount of money to the Ross Ulbricht Legal Defense Fund after he was convicted. I believe in justice, but I also believe he's a drug-dealing idiot and his lawyer was a drooling moron. So the goal is basically make it so you can't edit history. Good idea, but there are some issues with this. The first of all is bloat. That in order to verify that Alice has a balance, you have to potentially check every transaction back to the beginning. And so as a result, every full Bitcoin node needs to access the entire transaction history of Bitcoin. And so if you have 10,000 nodes, you've got 10,000 copies of the same data. That's just bloated. There is no way of deleting data. What's the best way to make your data set smaller? Delete stuff. You can't do that in a cryptocurrency. But this also gives a capacity problem. That in order to limit the bloat growth to 1 megabyte a block, as an early defense against spam, there's a limit. Globally, on a worldwide basis, Bitcoin can only process somewhere between 3 to 7 transactions per second. Yes, 3 to 7 transactions per second worldwide. And any Bitcoin taking over money requires centralized things that maintain databases. These are called banks. We've had electronic money for decades now. But there's an even bigger elephant, and that's the power problem. That currently, Bitcoin is consuming roughly the power consumption of Thailand for 3 to 7 transactions per second. Why'd this go out? Basically, this creates what's known as a Red Queen's race. So the Red Queen's race was a tale from Alice Through the Looking Glass. The idea is, as long as you have potential for profit, you get an increase in capacity. Efficiency gains get translated into more effort, not less power consumption. Let's suppose I snap my finger right now and make every Bitcoin mining rig on the planet use 1/10 the power. What will happen? We'll just get 10 times the mining rigs. And we'll be back to the same system where we are before, where we're basically burning the power of Thailand and creating a whole bunch of e-waste in the process. Bitcoin's security is proof of wasting power and e-waste. And there's no way to reduce Bitcoin's power consumption without either reducing the price or the block reward. If you care about the environment, and you care about the environment, I hope, because you have to live in it, you should hope that Bitcoin's value goes to 0, and the sooner it does, the better, because this is a measurable, significant amount of the world's global CO2 emissions. Basically, the space is dismal. The value is non-existent. That's why I say this lecture, apart from hash chains, Merkle trees, and Sybils, is about immunizing you against crap. Because this is a virus. Its harms are substantial. It's enabled billion-dollar criminal enterprises. It's enabled venture capitalists to do securities fraud as their business. And it's sucked in people. And so basically do one of two things. Either avoid it or help me make it die in a fire. Because I don't want to ever have to give this talk ever again. Because I want this space to die. And the final time, I thought the previous bubble pop would have done it, but it didn't. But I think this one will, because there's just so much collateral damage. Oh, and F. Matt Damon.